Good morning, everyone. I'm Roman Guskov from Samara State Technical University. I'm excited to share with you our report, Emergent Intelligence Platform for Developing Autonomous Resource Management Systems. This presentation involved new platform for developing ARMS, Autonomous Resource Management Systems, to increase adaptability and efficiency of enterprises. The proposed platform is designed to support the shift of paradigm of modern enterprises to new technological AI frameworks of Industry 5.0. As expected, the Enterprise 5.0 will be based on a full-scale digitalization of domain knowledge for automatic decision-making and the formation of collective intelligence systems, organized as a digital colonies of and ecosystems of AI systems. One of the prospective new classes of Enterprise 5.0 systems is Autonomous Resource Management Systems, ARMS, based on a model, methods, and algorithms for collective decision-making, ontologies, and multi-agent of technologies. ARMS can be organized as an autonomous digital twins of enterprise. The platform introduces Emergent Intelligence, EI for ARMS, development and autonomous resource management based on Professor Prigozhin's theory of complex adaptive systems. This theory explores how non-equilibrium states trigger cascade reactions, forming complex structures from simpler ones similar to market dynamics. Emergent intelligence systems are AI systems built on reaching a state of consensus. Our virtual market model uses software agents that compete and cooperate, mirroring energy flows and decision-making in multi-agent systems. Emergent intelligence inspired by biological swarms of bees and ant colonies. Together, working in a coordinated manner, these creatures form a complex self-organizing systems with a collective intelligence, which multiply their individual capabilities. We have developed a virtual market model where software agents of orders and resources can compete and cooperate with each other, operating with conflicts, interests, and bringing in new money as an analog of energy and spending it on establishing and breaking links and self-organizing into complex scheduling structures. This idea was advanced by a more complex multi-agent model of the demand and supply network and applied for a number of practical applications such as ARMS. ARMS is created as autonomous AI system based on ontologies and multi-agent technologies, taking on the functions of a dispatcher and logisticians. The systems works to achieve maximum profits from order executions. Software agents allow to build solution to any complex resource planning problem as a dynamic network of connection, flexibly changed in real time. Knowledge base enables you to customize the logic of agents work to the specific enterprise. In this case, ARMS will provide such system functions as support life cycle of each event in real time, combine adaptive scheduling and optimization, provide multi-criteria planning, generate and granulate plans, and work in parallel with the real enterprise. The ARMS systems are designed to answer key business questions for owners, managers, and employees of the enterprise. There are two domain versions of ARMS: real-time ARMS for end users and ARMS simulator. ARMS simulator assumed the work of a knowledge engineer ontologist to form an applied ontology and build an ontological model of the enterprise to fulfill the knowledge base, and work with an analyst who can simulate the operation of an enterprise with various orders and resources. The structure of a typical real-time ARMS for end users supplied to customers included the following main subsystems and their components: intelligent components, including ontology designer for setting on Thomas engine in ARMS RT to the specifics of the enterprise, which has its own web interface, and on Thomas engine for planning and optimizing resources, which does not have its own web interface called by API. The enterprise can combine the resource of ARMS RT and ARMS M using the second system to answer the questions: What will happen if, for example, to estimate the number of resources for a given planning horizon that is required to fulfill the predicted flow of orders? The main types of ARMS RT users involved in the main end-to-end business process of resource management and presented on the slide. Administrator for issuing logins and passwords, customers for the provision of services and system resources, dispatchers to manage available resources, executors of orders to specific technological process. ARMS uses three basic classes of software agents: agent of resource, agent of order, and agent of system. Our methods can be split to 5 stages of adaptive scheduling. Initial stage, preparation of the individual data for planning, identifying data that's useful for reducing computations, creating basic schedule. This stage is to form an initial draft but accessible schedule. Solving conflicts. In this process, agents continuously recognize conflicts and solve them by negotiations, by action-like negotiations and finding trade-offs. Consolidations of orders. This stage is the consolidation of unprofitable orders. An attempt is made to group orders into delivery chains which guarantee profitability of such groups. Adjustments of schedule. This stage is focused on the arrangement of stop points for fueling and catering executors, taking into account the norms of their work and rest. In future, customers and partners will be offered by the creation of digital ecosystems of ARMS. The Super EI solution is considered as an innovative solution for very large-scale enterprises and supply chains of enterprises. The Super EI solution is designed as a digital ecosystem of ARMS, where a few ARMS interact to take coordinated decisions. Analyzing the result of comparison with other algorithms, you can see that multi-agent method shows the best result that common algorithms for scheduling. Multi-agent method wins both in KPI calculations and planning time. The report discussed the option of developing autonomous resource management system based on multi-agent system and knowledge base, which can be implemented in real enterprise to increase business efficiency by 15 to 40%. At the same time, this type of systems and developing methods provide a new field for scientific research of creating self-organizing and evolving systems of strong intelligence of the future. A trend to think about business as an ecosystem began as early as 1993, triggered by the James Moore's article in Harvard Business Review. By now, complexity of our environment has increased to such a degree that it required self-organized digital ecosystems of ARMS to automate ongoing collective adaptive decision-making on resources. Under conditions of complexity and high dynamics of events which now prevail, the key success factor for enterprises is adaptability rather than the economy of scale. Thank you.